In this lesson, we're going to use the Boundedness Theorem to show the upper and lower bounds of real zeros of a polynomial function. Let f of x be a polynomial function of degree n greater than or less than 1 with real coefficients and with a positive leading coefficient. Suppose f of x is divided synthetically by x minus c. So if c is greater than 0 and all the numbers in the bottom row of the synthetic division are positive, then the function has no real zeros greater than c. On the other hand, if c is less than 0 and all the numbers in the bottom row of the synthetic division alternate in sign, with 0 considered positive or negative as needed, then f of x has no real zero less than c. In this example, we're asked to show that the real zeros of this given function has no real zero greater than 3. So since we're looking to see or to prove that there's no real zeros greater than 3, for greater than, we're looking for, once we do the synthetic division, that all the signs in the bottom row are positive. If they are, then that is true and proof that there are no real zeros greater than 3. However, if all the signs in the bottom row are not positive, then that would be a false statement. So let's go ahead and do the synthetic division there. And we're going to have a 3 on the outside as our divisor with, of course, our coefficients under the division symbol. So let's go ahead and get started by bringing down a 2. Multiply that with 3 to get 6. Bring down a 1. Multiply that with 3 to get 3. Bring down a 3. Multiply that with 3 to get 9. Bring down a 12. Multiply that with 3 to get 36. And I'm bringing down 37. Notice that all the signs there in the bottom row are positive, and so therefore that is proof that there are no real zeros greater than 3. And that is the Boundedness Theorem. In this example, we're asked to show that the given polynomial function has no real zeros less than -1. So we're going to look at the category under which we're looking for no real zeros less than. And that would mean that, and again, c here is -1. So when it's less than 0, c, it would fall under this category. We're looking at the bottom row being alternate in signs. So the signs should alternate. So let's go ahead and do the synthetic division to see if indeed the signs will alternate and prove that there's no real zeros less than -1. So we're going to have a -1 on the outside of our divisor, and we're going to go ahead and place our coefficients under the division symbol. All right, let's start by bringing down that 2. Multiply that with -1 to get -2. Bring down a -7. Multiply that with -1 to get 7. Bring down a 7. Multiply that with -1 to get -7. Bring down a -4. Multiply that with -1 to get +4. Bring down a 5. So let's take a look and see if our signs alternate, meaning positive, negative, negative, positive, in that order of whatever it starts with. In terms of this one, it starts with a positive, so we're looking for positive, negative, positive, negative, positive. And sure enough, they do alternate in sign, so there is proof that there is no real zero less than -1. All right, your turn. I want you to use the Boundedness Theorem to decide whether the statement is true or false. Here, the given polynomial that has no real zeros less than -1. So remember, when we're looking for less than, if the C, the number is less than 0, then the bottom row, the signs must alternate. So if the signs does not alternate, then that would be a false statement. So we're going to go ahead and do the synthetic division, which is your -1 on the outside, and then place your coefficients under the division symbol and go ahead and proceed with the synthetic division. Pause the video, and then when you're ready to reveal your answer, go ahead and restart the video. Okay, so what you should have noticed in your synthetic division that the signs did not alternate in the bottom row. You had a positive, negative, positive, negative. You were almost there, but then that last one changed. It changed the pattern, and they were the same, the last two. They did not alternate. So therefore, that is a false statement. That it has no real zero less than 1.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.